Alright, the lottery numbers are 8, 10, 13, 16, 19. Barber. And homework check, the regular homework.
There's a few of them I didn't understand.
Lewis.
I won.
So we're missing 4 technically, so that takes us down to 9. 1, 2, 3, 4, 5, 6. 6 out of 9 is 67%. Not very good. Alright, here are the answers. And that's for to review a sum and difference of 2 cubes and a difference of 2 squares. So we'll go through some flashcards again. X squared minus 25, what is that?
Difference of 2 squares.
It's a difference of 2 squares, and there's the factoring for that. What's x squared plus 25? Not factorable. 8x cubed plus 20, what's that one?
No, the sum of 2 cubes.
You can only factor out a 4, and then you're left with x cubed plus 5. And then 4x squared minus 10, what's that one?
I'm just factoring.
On this one, when you factor out, you have a 2 in that spot. What about this one?
Cubes.
The difference of 2 cubes. What about this one? Not factorable. This one. Can't factor anything out of it. What about this one?
Sum of 2 cubes.
Sum of 2 cubes, and there's the factorization for it. What about this one?
Not factorable.
No, you can take
Factorable. It's factorable.
It is the difference of 2 squares. What about this one?
Difference of 2 squares. You can take a 2 out of 50.
Yeah, that's right. You can take a 2 out of both, and this is what you end up with. X squared minus 25 is a difference of 2 squares. What about this one?
Difference of 2 squares.
No, it's you can just take a 2 out of it.
You can take out square roots, because this is a difference of 2 squares. There is another way that you could go about it. You could factor out a 4 from the beginning and be left with x squared minus 16, and then do you'd have to have the 4 there to start with, and then do x plus 4 and x minus 4. Either way would be okay. What about this one?
No, the difference of 2 squares.
Yeah, if you factor out a 3, you're left with a difference of 2 squares. So then you expand it out from there. What about this one?
Difference of 2 cubes.
Difference of 2 cubes. Yeah, look what happens here. If you want to see if it's a perfect cube, divide both of those powers by 3. Do the answers come out to be integers? You come out with x squared and then y to the 3rd. Those would be the cube roots. So yes, it's a difference of 2 cubes. And there's the factorization for it. What about this one?
Sum of 2 cubes.
Yeah, you can divide this one by 3 and this one by 3. So you're left with x cubed and y to the 8th as the cube roots. And there's the factorization for it. What about this one? It is factorable.
Difference of 2 squares.
When you take out a 6, you're left with x squared minus 25, so that's a difference of 2 squares. All right, try this one and bring it up. You can factor out a 4 to start with and be left with x squared minus 9 and come up with 4 times the quantity x plus 3, x minus 3. Or you could have done this. The square root of 4x squared is 2x, and the square root of 36 is 6. If you had either one of these, I'll take that. A difference of 2 cubes, so you should have x minus 2y. And then for the back end, you need 2 plus signs. Square this one, multiply them together, and then square that one, and don't forget the square symbol. This is a sum of 2 cubes. 125 is a perfect cube, so is 64. You have the power of 3 in each variable, so it's a sum of 2 cubes. The cube roots will be 5x and then 4y. Now your signs in the back end must be minus plus. 25x squared minus 20xy plus 16y squared. Don't forget the square symbol.